So init game, that's init game here. And so init game calls three methods. It calls start, it calls initialize, and it calls stop. And so my question was, which of these takes so long that they should be called outside the UI thread? So this is one of those things when you read a book in isolation, and where he comes up with some example where you do have to use your general knowledge of coding what these things are likely to do. So here is some animation here, and then we're telling the animation to start it. And so my guess would be that what that does is that the animation itself runs on some different thread, and we're just starting that thread. How long does it take to start a thread? I guess the real question is, does start return right away, or does start wait for the thread to finish? Like in your general experience. Yeah, it returns right away, right? Normally when you start in any kind of a background process, the call to start just starts it off, and then it returns immediately. So start wouldn't take a long time, and so that probably isn't going to be the culprit. Well, initialize, we kind of take that from the context. I don't think he ever told us what goes on inside initialize. He just says you should assume that this is something that could be taking a good long time. So that one does take a long time. And stop is the same thing as start. When we tell this background thread that does the animation to stop it is instantaneous. So the culprit here is clearly initialize. Let's see how we're doing here in Piazza. And let's see which of, and that was, so if you merge the two, I think that was clearly the majority answer. All right, let's look at the second question. So yes, and also the author then goes on to make us really nervous about this mutable map. Let's see where that map was. So let's first of all see where in this context here, why it was bad. So the stuff that goes on inside do in background obviously happens in the background. And so we're saying that when the button is clicked, then the async task should execute, and when the async task executes, then the do in background happens. And immediately after kicking off the background task with execute, that's really just like the start that you saw before. Immediately after kicking off the background task, we now clear this map. Now, no one in their right mind would program this, or not hope, because now this thing is cleared, while at the same time something happens in the background that presumably needs to use them. Is it the same one? What the background thread here uses params. Is params the same reference as vals?
Yes.
It is indeed. And how do we know that? Because here we're passing vals to execute. Whatever gets passed to execute gets put into the parameter of do in background. We can put in more than one in here, but we only put in one. And so params and vals are really a reference to the very same object. So that very same object is now mutated in one thread and presumably viewed in another thread. And so that is a classic race condition. That's not going to work. So, so my question was, what's the remedy? So one of them was, what if you call clear and post on an on-post update? Is it going to work?
Yep.
Yes, it is going to work, because the control flow works that it first calls do in background, and after do in background has returned, then it calls on post update. So there's no danger there. We're not touching the map until afterwards. And the fact that they run on different threads is kind of immaterial here. What matters is that one of them has returned before the other one enters. So doing it on post update is perfectly safe. And that was kind of one reason to use on post update, that you know for sure that when on post update is called, the background processing has finished, and you can harvest whatever its result was. And the next one I asked is, if you call clear at the end of doing background, so if we were to call it clear here, would it work? Yes, because in here we're using the params map, then we're calling clear on, we would have to call params.clear here, I suppose, and we'll work fine. Because we're first using it, and then in the same thread, after we're done with it, we're clearing it. It's not so clear why one has to clear it in the first place, but that's the context that the author has provided here. So yeah, that would work fine. And the third option is, can you clone it? Well, what would happen if over here we would pass vals.clone? Oh, well, fine. Then this over here we would get a copy of the map, a separate independent copy, no longer a reference to the same object. And that copy has all of the stuff in there, and it persists even if the original is clear, then the copy is still there. Seems a bit of an expensive way of doing it, but it would definitely work. So any of these three ways does work. The only thing that doesn't work is if you read something in one thread and you mutate it in the other thread. That would be fatal. Yeah?
Are all of the methods of the async task done on the same thread, or is it only doing background?
No, they're not done on the same thread. They're done on different threads. The doing background is done on its own thread, which is created for you. You don't even have to bother doing it. Whereas the on post update is done in the UI thread, and that is important because on the UI thread you're allowed to modify the user interface components. You're not actually allowed to modify any user interface components in the background thread. So in the background thread, you would not be able to call set text on a text feed, for example, because there might be some other part of the UI that currently reads from that text component. It's important for the UI to be single-threaded. And so the way that this works is that if you think about how a user interface works, it's always event-driven. That when a user clicks on a button, then the button handler gets called. When a user swipes something, some other handler gets called. And those handlers get called one after another. What the async task does is when it does the on-post update, it posts an event and says, please carry out this action at an opportune time. And so that way, those things are always serialized. All right, let's see. All right, this was perfectly divided except for the wrong answer, which got the minority vote. So think through this one again, and if you're confused about this, ask questions. It's a perfectly good idea to ask questions about the reading in Piazza, preferably before the class even. That way I have some idea of where you got stuck with the reading. So there were a couple of people who were very confused, I think, about this kind of nested syntax and had never seen that before. And if you're in that situation where you haven't seen these anonymous classes, then here's my suggestion. I put up a link on the main page to oops, I should have put this in a bullet, to a classic text on this called Core Java. Here it is. And so if you look here into section 6.4 on inner classes, that explains the syntax of how inner classes work and anonymous inner classes and all of that. So if for whatever reason you haven't seen that, then definitely look at that, because as you've seen in this book, every one who writes more professional level Java programs just uses that syntax. You were supposed to have seen that, I think, in CS 151, but if you've never taken 151 yet, then that would explain that. Or if you've just learned your Java somewhere else and they weren't all that thorough. All right. And finally, did I close it? I just wanted to know whether the homework was okay. Well, if most people felt the homework was just right, then that's good. All right, that was just from my feedback. Wasn't ready to double check that 2 was just right. All right. Okay, so today we're going to just do a few things in the lecture in the lab. We'll make those buttons work that you showed in the homework. The homework you put the buttons there, but obviously when you click one of them, nothing happened. We're going to learn how to move from one activity to another and how to transport information from the original activity to the follow-on one. And then we're going to learn how to build stuff on the command line. So, making buttons work is, what you want to achieve is that when the user clicks a button, that some method gets called. And of course that method will get called on the UI thread. And so you have to associate the button with the method to be called when the button gets clicked. There are 2 different ways of doing it. I should say that the button gets the view in which, the method, the callback method, gets the view in which the button is contained, and it shouldn't return it. So you can write that method and give its name in the XML. So I've done that over here, where you see this is the view XML, and over here you see where I give the name of that method. And then that means that somewhere in the activity class, you need to implement sendMessage. Now, that's one way of doing it, but the disadvantage of that is that you mix behavior and layout in one file, and that's generally not considered the best way of doing it. I mean, it seems easy at first, but generally the better way is of saying that anything that has to do with behavior should be in the Java code. And so that's what you see down here. And it's a little bit more complicated. We have to find the button. And that's always somewhat laborious in Android. Find view by ID, get the button ID, cast it to a button because find view by ID could return any component. And then you have to set the on-click listener. And you have to set it to an object that implements a particular interface. And that interface is view.onClickListener. So here again you see an anonymous object of an anonymous class where we're making a subclass of view.onClickListener, or a class that implements this interface, and then in that class we're defining the method. Now in this case you must call the method onClick. You have no choice. Over here you could call anything you want, but here it must be called onClick. Why?
You're overriding it?
Yeah. So you're overriding something in this interface. So when you look up this interface, there'll be a single method called onClick. And when you override the method, you have no choice. You have to give it the same name. Then inside here, you put the action of whatever it is that you want to happen when the button is clicked. And depending on your user interface, that might be simply to change something in the current view, or it might be to transition from one view to another. So, if you think of our quiz example, we might want to have something where when the user clicks on A, B, C, or D, that afterwards it transports them to a new screen that says whether they did it right or whether they did it wrong. So in that case, one would change what's called an activity. Remember, an activity is a screen. And so it turns out that changing from one screen to another is not quite as simple as you might think in Android. You have to, every time that you want to switch to a different view, you do it through what's called an intent. And an intent is something that pervades the whole Android architecture. And in general, an intent is declarative. You say what you want to do, but you don't say how you want to have it done. For example, an intent might be, I want to show a web page. And so you would then build an intent object that indicates in some way to show a web page, and of course it indicates with some extra parameters which web page to show. And then it's up to the framework to switch to whatever browser the user has indicated is their default browser. Or if there's more than one browser, can I have a show of hands? Who of you has an Android phone, a reasonably recent Android phone? Okay. For those of you who don't, what happens when you watch a web page and you have two browsers installed, say Chrome and Firefox, then it's going to ask you which of the browsers do you want to use, and you get a choice. Do you always want to use this one or just this time? And if you say always, then from then on, of course, it knows what your favorite browser is. But if you say just this time, then it'll keep asking you. So the application gives the intent to show a web page, or to play a movie, or to whatever. And there's many situations where an application will rely on this architecture. For example, when you use Dropbox and you want to view a PDF file, you can have more than one application that's willing to show PDF, and you can then pick yours. So that's the general thing. But then now they use the same structure even in a single application, where it wouldn't be strictly necessary. And so in this case, I know exactly where I want to go. I want to go to a new activity. There's a class for that activity. And then I build the intent in that way that, say, go to that specific class. That's what's called an explicit intent. And it's a little bit cumbersome for us that one has to go through the structure, but one gets used to it quickly. So when you construct an intent object with an explicit intent, you just give the class that you know that is supposed to take over. And then you also give it the current view. Now I put in your outer class this because when you do this inside a button handler, and if you were to just say this, then this would be the button handler. And so you want to actually have the view that surrounds it, and you have to give the class name, such as main activity.this, and define the practice. So you construct the intent, and then you simply call start activity of intent. That's a method of the view, and that starts the new intent. And so that then gets overlaid over the one that you have. So we'll practice that in the lab, but it's pretty straightforward. Now, the thing, though, is you should think of these intents as kind of services that your application provides. So anytime that you have a screen, you should think of that screen as a service that's willing to display some kind of stuff, and that kind of stuff should be given as parameters to that activity. And so rather than relying on global data, where your application just reads some global data structure, you should think of each of these screens to be as self-contained as practically possible. Each of the screens should be given all of the information that it needs to show itself. So for example, in the main screen, the one they've done the homework, the best way of doing it would have been to, when one fires up that intent, that main activity, to say, use this particular URL. And then somewhere else on the stack of views, there could have been another instance of it that was fired up with a different URL. So every time that you have a view, you want to think, what are the parameters of it? And then, of course, you need to pass the parameters when you make the transition from one screen to the next. And so that's done with this put extra stuff. So an intent has some arbitrary extra data. There's like a hash table of data in there. And you have to come up with a string that gives that is the key for that data. So, for example, in the quizzes, we might have as a key the question, and we might have as a key the answer that the user provided. And then you would have to, so you have a quote question, quote answer, quote, some such thing. That's a string. So you can think of an intent having a little hash table inside. Now, the objects that you can pass are integers, strings, and so on, and any kind of serializable object, which is what we're going to be doing. Then when you retrieve in the other view, so now you put this into this in the current view, then you call, what was it? How do you switch to the set intent? start activity. Then you call start activity. Now the other activity kicks in, and the other activity calls get in, gets the intent that it was started with, and then it calls one of those get extra methods. There's it. Get int extra, get string extra, and so on. And you should look them up in the API docs when you need it. So, and when you do this kind of thing where you transfer some piece of knowledge into a view, it's always a good idea to have these views not just a string or a list of strings, but to have them be domain level objects. So in our situation here, we're going to be passing an object of type question. Of course, we could just pass that array list of 5 strings, but that makes the code really hard to read because now there are 2 different pieces in the code that have to understand the convention that the first string is the question and the next 4 are the options and so on. So we're instead going to make a class question and put the question object into the new intent over here and retrieve that same question object here. So that way the storage is decoupled, one of them puts it in, the other gets it up. And so these objects must be serializable. If you've never known anything about serialization, again, it would be a good idea to go into Core Java and find out where it talks about serialization and read those sections. Generally, serialization is a way that you can take a Java object and turn it into a bunch of bits, and then when they get deserialized, then the other part can take them from the bunch of bits and turn them back into the object. So really, when the object gets moved from one intent to the other, it gets stored into bits, and then it gets a copy of it gets reconstructed in the other activity. So it's a standard mechanism. We'll talk about it a little bit more later. Right now, just make a note that if you're not really comfortable with that process, to study up on it when you have a free minute. All right, finally, what I want to practice in the lab is command line builds. So you've noticed that when you use Eclipse, it's kind of nice. You just type away, and ever so often it rebuilds your application in the background. And you'll get error messages or not, and eventually, you'll just click the run button, and you don't ever have to worry about compiling the application by hand. And that's really nice when you code away. Unfortunately, the way it does the rebuilding is it uses all of the various settings in your machine, of which there are hundreds. And so when the build that you produce may be subtly different from the build that your neighbor produces. So for reproducible builds, that's not the way to do it, because there's just so many settings in Eclipse, you can't control them all. You want to have some automated way of doing that. So Android uses Ant for build automation. Ant is a tool that's been around for a long, long time that runs build scripts that are written in a particular XML syntax. And it's very likely that one time in your life you're going to have to actively manage an Ant project. So at one of these days you're going to have to learn what all of that XML is. Did anyone use Ant so far? Nobody used Ant? What do you use? How do you automatically build your Java projects? That's not an automatic build, that's a manual build. Okay. Maven, oh, yeah, Maven is fine too. But they, for whatever reason, chose Ant and not Maven. Maven has its own set of issues. Yes. So if you use Maven, you can just think of Ant as being a very liberal way of running Maven. So we'll just do it by experience right now, and when we have some time, we'll dig into what that XML actually is. So the grader, for example, if you think about it, has to do, 18 or so of these projects? The grader is not going to sit there and fire up Eclipse 18 times and make a new workspace, and add that thing into the workspace and click on all of those buttons. The grader is, of course, going to automatically build your projects and run them off the command line. That's the only way to do something when you have to do it 18 times. And when we build this on the build server, that's what the build server is going to do. So, might as well get in the habit right away. When you make a project the first time, and in this class we're going to be doing this much more often than one normally does. Normally when you build an application, you're going to be monkeying with the same project for weeks and months on end. And here we're having, 2, 3, 4 new projects a week, so that's a little bit abnormal. Anyway, when you make a new project, you have to tell, you have to build what's called the build.xml file, the file that contains the build script. There's a nifty tool that builds it automatically. If you put in this mumbo jumbo, then it'll give you a build file. So you do this completely outside Eclipse. Eclipse is shut down at this point. You still want to be able to compile and run your application, so you need to fire up the emulator, and that's done with this command here. The ampersand means it's a graphical application, and so it spawns it in the background, and you get your command line back. Then you will want to build your project with this command here, and that completely recompiles your project. Then you want to load it into the emulator, and you do that with the mumbo jumbo that you see here. And then finally, when you're done, you can uninstall it. You probably don't really have to do that, but the grader will want to do that, because otherwise the grader has 18 applications called HW1 in their virtual machine, in their emulator, and it's kind of tough for them to tell them apart, or they might step on each other or something. So you can manage the life cycle of an application completely with the command line. All right, so let us practice that. Yes?
How would you do that if you had your phone plugged in instead of using the emulator?
You can also do that, and then you would have to look up, obviously you don't start the emulator then, you would have to look up in the install on what the magic thing is to push it on your phone. There is some way of doing it. And the official way of doing it is you Google for installing app on the Android app on the phone with a command line, and you look for the first Stack Overflow question that comes up. And someone somewhere is just going to give you the command line for this, and then you'll tweak it so that it works for your context. Yeah, but it totally works. And so you can do any of those things, both with the IDE and with the command line. And that's just a general theme in modern toolkits, that sometimes it's more comfortable to do one and sometimes more comfortable to do the other. And so they tend to provide both ways nowadays. And particularly, of course, when you ask a question on Stack Overflow, it's a heck of a lot easier for someone to paste you the command line of the command that does it than to say, well, click here, and if you have version 17.3 of the IDE, the button is over here, otherwise it's over there. So, so the command line is king in these things. All right, so here's the reading for next class. So, let me know if you have any issue with the reading, and I'll be glad to answer questions on Piazza. Okay, so let's do the lab. So switch the roles. Use the same partner that you had last time, but switch the roles. Whoever was described as the driver now, and just get going with the lab. Oh, the lab. I have to do one thing. The lab uses the solution of the homework. And I said I put the solutions up, and I have not yet done that. So I will do that in the next 2 minutes. Go ahead with your lab thing. By the time that you're done, the solutions will be